Yes, in this video we will see property and support assignment in STAAD Pro. So in last class we completed the modeling. So if you open your STAAD Pro software, we completed this frame structure, modeling of frame structure. Okay. So we completed geometry. So today we will see how to assign material and section properties and supports. Okay. So your material is structural steel, structural steel. So assume if I am using mild steel, so its yield strength Fy, it will be 250 Newton per millimeter square, and ultimate tensile strength Fu. So Fu it is 410 Newton per millimeter square, and Young's modulus. So for steel it is 2 into 10 power 5 Newton per millimeter square. Okay. So 1 Newton per millimeter square, which is equivalent to 1 megapascal. Okay. Or 1 Newton per millimeter square, which is equal to 1000 kilonewton per meter square. Okay. So when you open your STAAD Pro, you go to materials. So you have default materials like steel, concrete, aluminum, timber, stainless steel. So you select this steel, you go to edit. Here you can edit. So here you can edit the properties. So you just take a screenshot of this: Young's modulus, Poisson's ratio, density, thermal coefficient, critical damping, shear modulus. Okay. Next, yield stress, tensile strength Fu, yield strength ratio, tensile strength ratio. You just take a screenshot of this. So here we will create a table property value and its unit. So first property is Young's modulus. Young's modulus. So its value is 2 into 10 power 5, 2 into 10 power 5 Newton per millimeter square, or 2 into 10 power 8 kilonewton per meter square. If you check the STAAD Pro, so here it is in kilonewton per meter square. Kilonewton per meter square. So we will follow this one. 2 into 10 power 8. 2 into 10 power 8. So unit is kilonewton per meter square. Second property is Poisson's ratio. Poisson's ratio, so which is denoted by mu. So for steel it is taken as 0.3. It is unitless quantity. Next is density. Density. So 78.5 unit will be kilonewton per meter cube. So next is thermal coefficient. Thermal coefficient, which is denoted by alpha. So it is 1.2 into 10 power minus 5 per degree Celsius. Per degree Celsius. Next it is critical damping. We will use it as 0.03. Critical damping, we will use it as 0.03. So next is shear modulus. Shear modulus. So which is calculated as shear modulus G equals Young's modulus E divided by 2 into 1 plus mu. So your Young's modulus is 2 into 10 power 8 divided by 2 into 1 plus mu. Mu is 0.3. So it is 2 into 10 power 8 divided by 2 into 1 plus 0.3. So it is 76.9. So the final answer is 76.9 into 10 power 6 into 10 power 6. So you can write like this: 7.69 into 10 power 7 kilonewton per meter square, or you can take this as 7.7 into 10 power 7 kilonewton per meter square. So this is your shear modulus. Okay. So these are material properties. So these are material properties. So design properties. Next we shall see design properties. Again we will create a similar type of table, that is property, value, unit. So first is yield stress, which is denoted by Fy. So it is 2.5 into 10 power 5 kilonewton per meter square. Okay. Next, ultimate tensile strength. Ultimate tensile strength. It is Fu. So 4.1 into 10 power 5 kilonewton per meter square. Next is yield strength ratio. So that is Ry, which can be taken as 1.5. Tensile strength ratio Rt, which is 1.2. Compressive strength, at this time it is not required, so we will take it as 0. It will be used in the case of concrete. Okay. So you go to STAAD. So you just remember these values. You have to input these values to STAAD Pro. So two into 10 power 8, that is 2.0 e power 8, Poisson's ratio 0.3. So density 78.5. Okay, you go to, again you select this steel, edit, 78.5. Coefficient of thermal expansion 1.2 into 10 power minus 5, it is correct. Critical damping 0.03, and this shear modulus, it is 7.7 into 10 power 7. So it is 7.7 e power exponential power plus 7. Next, yield stress, it is same, 2.5 into 10 power 5. Tensile yield stress, tensile strength 4.1, 4.1. Yield strength ratio 1.5, tensile strength ratio 1.2. Okay, so you just click Okay. So you created a steel. You can delete this concrete. You select this concrete, go to delete, click on OK. You select this aluminum, delete, delete. You select this timber, delete, OK. Stainless steel, delete, OK. So if you want to create anything, you just click on this create. See here, you can create aluminum, concrete, steel, timber. So if you select concrete, see the properties will change. So we have created material called steel with these properties. With these properties. Okay. Then how to assign? How to assign? See here. In case of assignment methods in STAAD Pro, we have four assignment methods. First one is assign to selected beams, assign to view, use cursor to assign, assign to edit list. Okay, you have four assignment methods. So if you select, I will number like this 1, 2, 3, 4. If you select first assignment method, so first assignment method is assigned to selected beams, which means if you select this option, assigns material only to already selected members. See here, if you select first option, it will assigns material only to already selected members. Already selected members. So if I select these two beams, you just hold a control button on keyboard, you select these two beams and you select this steel. So first you select this property steel, then you select these two beams. Okay, so you select this option assign to selected beams. So you click assign. Yes, see here, these two beams are assigned with the property steel. If you want to assign the property for this column, you select this, first you select this property, you select this column, assign to selected beams, you click on this assign. Okay, the material is assigned. So if you select second one, that is assigned to view, assigned to view, what will happen? So STAAD will assigns material to all visible members. All visible members. See here. If you first you select this steel, you select your second option assign to view, assign to view. What will happen? It will STAAD will assigns material to all visible members on this window. So you click on this assign. Yes, see here. So STAAD will assigns material to all visible members. So all the members are assigned with steel. Okay. So if I use undo, okay. So this is your second option called assign to view. So you delete this property. You can use any one method. Out of these four methods, you can use any one as per your convenient. So use cursor to assign. This third option is use cursor to assign. Click members one by one to assign material. So if you select this use cursor to assign, so you need to click members one by one to assign material. Okay. So you just delete this, create a property. So you select this property, you select this use cursor to assign. So for which you have to click members one by one to assign material. So you select this option, you click this assign. You can individually click whatever the material you need to assign. Okay, click members one by one. So at the end you click this assign. See here, this is your third option. Okay, next fourth is assign to edit list. Fourth option is assign to edit list. So if you select this fourth option, assign material using member numbers. It will assign material using member numbers. Okay. So for which to get the member numbers, there is a shortcut. Member numbers. To get the member numbers, there is a shortcut keyboard command called shift B. So you click Shift B. See here, member numbers are visible. Okay. So these member numbers are visible. So this member number is 137, 23, 61, 99, 142, 143. If you select this assign to, I will remove this. So if you select this assign to edit list, you just type this member number 142 space 143 space 144 145 146. So I have entered member numbers 142, 143, 144, 45, 46. Okay. So you just click this assign. See here, whatever the member numbers that you have provided in the list are assigned with property. Okay. So these are the 4 assignment methods in STAAD Pro. So according to your project requirement, you can use any method. So if you want to assign same material property for all the members, then which is the easier method? So you select this steel, assign to view, you select this, click on this assign, yes. Okay. So this is how you can assign materials in STAAD Pro. So next will be section properties. So next 20 to 30 minutes discussion will be on section properties. So for which you go to STAAD properties. Okay, properties. You click here prismatic. So this is properties. You should be working in properties tab. You click on this prismatic. You click on this prismatic. See here. These are different cross-section shapes you can define in STAAD Pro properties. One is circle, circular, rectangle, T-section, trapezoidal, general sections, tapered eye, tapered tube. Okay. So this is how you can create. So first is prismatic. What is prismatic? A prismatic member has a constant cross section throughout its length. Example, a RCC column. A RCC column 300 by 500. Okay. The size is same throughout the length. Okay, this is prismatic. Prismatic means constant cross section throughout its length. So that is, first is circle, next is rectangle, next is your T sections, trapezoidal, again you have general, tapered eye, okay, tapered tube, and at the end you have assigned profile. So these are the different cross section shapes you can define. So circle. So circle used for circular columns. Circular columns. Okay. Piles. Circular shafts. And in case of chimneys. So for circle, you need to only define diameter. You need to define diameter. So you go to E-tabs. If you select circle here, it will ask you to enter the diameter here. And at the end, you need to select the property. Your column is of what diameter and what property. So next is rectangle. Rectangle. Which is used for RCC beams. Okay, RCC columns. So for rectangular cross section, the inputs are depth and width. So depth is YD and width is ZD. It is defined in STAAD. So you go to STAAD. If you select rectangle, see here, you need to define depth and width. So depth is YD and width is ZD. Okay. So next is T sections. T sections are used in the case of T beams or in the case of flanged beams. Okay. Trapezoidal. It is used in the case of retaining wall stems. Retaining wall stems. And whenever you need variable depth beams. Variable depth beams. Okay. Next is general. Okay. So general means you want to manually enter area and moment of inertia. Okay, from this general you can create custom section properties. Okay, so you go to general. You need to define AX, AY, AZ, IX, IY, IZ. Okay, you can create custom section properties. So this general tab is used for creating custom section properties. Next will be tapered eye. So which means steel eye sections whose depth varies along the length. Okay, so this is tapered eye sections. So it will look like this. So depth varies along the length. So if you take cross section here, so depth will be D1. Okay. Next, if you take cross section at this level, so depth is D2. Okay. This tapered eye is used for creating tapered eye sections whose depth varies along the length. So next is a tapered tube. So these are circular hollow sections with varying diameter. Okay, so tapered tubes. So at one end it will be like this. At the other end it will be like this. So these are nothing but the tubes. So at this section diameter is D1. At this end diameter is D2. Circular hollow section with varying diameter. Next is assign profile. So it is used to import IS steel sections, other standard database sections. Okay, so you go to prismatic. So first I will remove this beam numbers, that is shift B. To hide this, see here, to hide this nodes you can use shift K. See here, now the nodes are not visible. So on the keyboard you just press shift K. Yesterday it was not working, so now it is working. Shift K and shift B. Shift B is for beam numbers. Shift K is for hide and unhide the nodes. So I will go to prismatic. So I will create a circular column 0.3 meter. You just add. I will create a rectangular column. So 0.6 by 0.2. This is depth. This is width. Add, close. So I will select this column. So for this column I will assign rectangular section. You select rectangular from the list. Assign, yes. Okay. For this column I will assign circular. So hold control key on keyboard to select multiple elements. So you go to assign. So this is property 1, property 2. Property 1 is circular, 2 is rectangular. So you go to beam tools, 3D rendering. See here. See here. This is your rectangular column and this is your circular column. Even you can change the orientation. You can orient this column in opposite direction also. Okay, we will see that later. Okay, so now we will see how to create tapered eye section. I will show you how to create tapered eye section. So to create tapered eye section, so we assume depth varies from 600 millimeter to 900 millimeter. Web thickness 12 millimeter. Top flange, so width will be 250 and thickness 20 mm. And bottom flange 300 by 25 mm. Okay, so we will now create tapered eye section on STAAD. So you just open STAAD, you go to properties tab, click this prismatic tapered eye. See here, F1 is depth of section at start node. So here units are in meter. So starting depth is 600 millimeter, which means 0.6 meter. 0.6 meter. Next, web thickness 12 mm. It is 0.012. Depth at end node, it is 900 millimeter. Top flange width 250 mm, which means 0.25. Top flange thickness 20 mm, which is 0.02. Next, bottom flange width, it is 300 mm, 0.3. Bottom flange thickness 0.025. So material is steel. You click add. See here. Here you have the section taper. Okay. So you select these beams and you select this property taper. You click on this assign to selected beams. So assign, yes. See here. This is your tapered section. So in 3D, it will look like this. See here. So this is your tapered eye section. See here, you can use different views. See here, this is the center line. So it tapers along both the faces. See, at the top face and at the bottom face. It tapers along both the faces. So here you have the different different views. Different views. Okay. If you want, you can rotate it. See here. You can rotate your model. You can rotate like this. Okay. So if you don't want this property on this window, properties window, you just select this taper and you delete it. Okay. If you are using older version of STAAD, if you are using older version of STAAD, see there may be some changes. See here, this tab is for STAAD Pro 2025. Okay, in case of earlier versions, this standard it is named as values. Okay, this legacy is named as section database. These values are user table. This instead of prismatic, there may be materials. Okay, so don't get confused. Okay, this is how the name appears in older version of your STAAD Pro. So you can bring any section here. So you click on this legacy. Okay, so you go to Indian. Okay, here you have a shape, I shape, M, W, T shape, your channels, C section, angle, tube, and pipes. And you have Jindal manufacture sections according to Jindal manufacture. And you have Tata Tata Structura. Tata Structura. These Tata Structura manufactures only hollow sections. Only hollow sections. Okay. So you can use any code sections. So if you go to Indian, okay. So if you want channel, okay. So you click ISMC 100, you click on add. Okay, you just close this tab. Okay, you select any members, you go to assign. Yes, here that property is assigned to selected beams. So you go to beam tools, 3D rendering. See here, this is ISMC 100. This is your channel section, C section. Okay, you can bring ISMB 600 also. So you go to legacy, ISMB. ISMB 600. Okay, you have angle sections. See here, in case of angle section, I will select ISA. Okay, I will select length here. ISA 200, 225. I will select this option. Long leg back to back. You click add, close. You select the same two beams. You go to assign. Yes. So now you go to 3D view. See here. See here. So you have two angle sections connected back to back. Connected back to back. Okay, see here. Either you can provide clearance also. Clearance means distance between these two angles. This is as per your design requirements. Okay, you can bring any type of section here. So you go to legacy. So I will bring ISMC 150. Channels ISMC 150. Okay. So here you have single section, double channel back to back, front, double channel front, which means single section means it will be like this, single. Double channel back to back means the arrangement will be like this. Your channel sections arranged in this manner. Double channel front to front means the arrangement will be like this. So this is single section, and this is double, but back to back. This is double front to front. Okay, so we will create one section. So ISMC 150 front to front. So spacing 0.5. You click on add, close. Again you select these two beams. You select this property, assign, yes. So you go to beam tools 3D, see here. So two channel sections, front to front. This clearance is this clearance is 0.25 meters, which I have given in the tab. Okay, this is how you can create any section. So next we will see how to rotate sections. We will see how to rotate sections. In STAAD Pro, the beta angle is used to rotate the members cross section. So we will use a command called beta angle. Okay, this command is used to rotate a member's cross section. So you go to STAAD, you check this orientation of this column. You go to beam tools 3D. See here, it is I will select complete model. You on keyboard you just press Ctrl A. You go to beam tools 3D rendering. See here, this rectangular column. This rectangular column, it is oriented like this. This is oriented like this. Now I will change the orientation to like this by using command called beta angle. Okay, so first you go to properties. You just be here at beta angle. You click on this beta angle. You go to create beta angle. So you give angle 90 degree. Okay, I will create another one. Create beta angle 45 degree. Okay, so first I will select this column. So select beta 90 degree. You go to assign, yes. See here. Now go to beam tools, rendering view. See here. Now the orientation of the column has been changed. Orientation has been changed. Okay. So what if I use beta angle 45 degree? Okay. You just close this. You select all the columns. You select beta 45. You go to assign, yes. So now you go to beam tools, check the 3D rendering. See here. Your column is rotated to 45 degree. Your column is rotated to 45 degree. Okay. How to remove this beta angles? You just click this beta 45. You click here, delete. Okay. So next we will see support assignment. So next we will discuss about support assignment. See, if you have a portal frame, simple portal frame like this, in this portal frame you have two types of joint. So this joint is, I will name it as 1. It is fixed. This joint is fixed joint. Whereas this I will number it as 2. It is rigid joint. It is rigid joint. So what is the difference between this fixed and rigid joint? Okay. Fixed and rigid joint. So basic meaning is a support condition that restrains all degrees of freedom. So in fixed, all degrees of freedom are restrained, both rotational and translational. Both rotational and translational. Okay. Next, in case of rigid, it is a connection between the members that transfers moments and forces without 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 relative rotation. Okay, which means here the angle is 90 degree. Here the angle is 90 degree. At rigid joints, these members all will rotate, but their relative angle remains the same, which means it will rotate like this. So after rotation, the relative angle remains the same. So this is the major difference between fixed joint and rigid joint. Okay. Next, location. So fixed joint we will get at supports. So this rigid joint is at member intersections. Member intersections. Okay. So in STAAD, there will be some default or some standard available supports and customized supports also. So standard available supports are, one is your pinned support, another one is your fixed support. So these are standard available supports. Okay. So you remember one thing, supports are always assigned to nodes. supports are always assigned to nodes, not for members. So we will create fixed support and we will see how to assign this in STAAD Pro. So you go to STAAD Pro, you go to supports tab. See here. Here you click on this create. See here. These I told you in the beginning, standard available supports. So there are two. One is fixed, another one is pinned. These are standard available supports. And customized supports. You have customized supports are fixed but enforced but. Okay, these are customized supports. Okay, even you can create spring here. Okay, tension and compression only springs. Okay, so we will create fixed support. So you click on this fixed. See restraints. See the restraints. All the degrees of freedom are restrained. Fx, Fy, Fz, Mx, My, Mz. Forces as well as moments. You click on add. See here. There is your support. Next you go to view. You go to front elevation. You go to select. You click this node cursor. You select all the bottom nodes. Okay. Again you go to view, 3D view. See here. Your bottom nodes are got selected. Now you click on this assign. Yes. Oh, it is terminated. Okay, you go to supports. You go to create a fixed support. You select this support. You go to view. You go to this front elevation and you go to select node cursor. You select all the bottom nodes. Again you go to view, 3D view. You go to assign. Yes. See here. See here. This is your fixed support. If you want pinned, support means you delete this support. Again you need to create pinned support here. See here, for pinned support only translational or degrees of freedom are restrained but not the rotation. You click add. See here, it is your pinned support. Same procedure. You go to front elevation. You go to select node cursor. You select all the bottom level nodes. You go to view, 3D. See here, the nodes with red color are got selected. You click this assign. Yes. See here. This is your pinned support. Okay, so you use fixed supports for all the columns. You assign fixed support. Okay, so in the next session we will discuss about load calculations. In the next session we will discuss load calculations. Okay, you go to file and you click this save.